right, so for this example, there's a couple of things that we need in order to create a linearization. So the first thing is I want to create some approximation for the square root of 11. Well, we could always go to a calculator. Obviously, we can go to a calculator. But the idea is that if I want to find the square root of 11, approximate that, the first thing that I need is a function. So I need a function to approximate square roots. Well, that's going to be easy, right? The function that best approximates square roots is going to be the square root operation. So we can say that f of x equals the square root of x. So the other thing that I'm going to need in my linearization formula in Taylor's form is the derivative. Well, we've done the square root of x quite a few times by now. You can derive it if you want. If you need to pause the video and do that, by all means. But the derivative is going to be 1 over 2 square root of x. So the last thing we need is some nice, easy to find values of a. So I gave them here. So this first kind of row in the table means x is 11. So the linearization of x, which I don't know why that's a super big x, that should be a lowercase x. The linearization of 11 is going to be equal to f of, I need some nice easy value that I can take a square root of, so 4. I can take the square root of 4. So my value of a is 4. We're going to add on the derivative at 4, and x minus a, well, our value of x was 11, and our value of a was 4. Put another way, the distance between the point that we want, the x value, the point that we want, and the value that we're using is 7 units. All right, so if we do that, we're going to get f of 11 is approximately equal to the square root of 4, right? Because f of 4 is square root of 4 plus 1 over 2 square root of 4 times 7, right? That's the distance. So then if we get this approximation, right? So f of 4 is approximately equal to 2 plus 1 fourth of 7, and 2 plus 1 fourth is 7, 2 plus 7 over 4, 2 plus, what, 1.75 is 3.75. So what we just found is that an approximate value for the square root of 11 is 3.75. That's not too bad, right? We can break out a calculator and kind of check it, but that would be an approximation. Now we can obviously do a little bit better than 3.75 by shortening the distance between 11 and a nice, easy to find value. So what's another easy value that we can take the square root of? Well, 9. So let me see if how this improves our approximation. So again, x is 11. We want to find the linearization of 11, which is going to be f of 9 plus f prime of 9 times 11 minus 9. So that means that f of 11, right, these are our values of x, is approximately equal to the square root of 9 plus 1 over 2 square root of 9 times 2. So that's going to be 3 plus this 2 here and that 2 here are going to cancel out. So we're going to get 3 plus a third. So f of, whoops, that should have been f of 4. So f of 11 is approximately 3.3 repeating, right? So this should be a better approximation than 3.75 because 11 is closer to 9 than 11 is to 4. So I'll kind of bang out these last two quickly, right? So 11 in both of these. So our linearization of 11 is going to equal to, in this one, the square root of 16 plus f prime of 16 times 11 minus 16. This bottom was going to be f of 100, f prime of 100, 11 minus 100. So f of 11, or linearization, or approximation, is going to be the square root of 16. Down here is the square root of 100, plus 1 over 2 square root of 16, plus 1 over 2 square root of 100. 11 minus 16 is negative 5. 11 minus 100 is negative 89. So then we can get f of 11 is 4 plus negative 5 over 2. So this is going to be negative 5/8 when we calculate this. So 4 minus 5/8. 5/8 is, what is that? 6.25. So we're going to get 3.375 as an approximation. So better than 3.75, but probably not as good as 3.3 because 2 is a smaller distance than this -5 is. And then finally, this last one's going to suck, right? Because we're using 100 to approximate 11. So we're going to get 10. This is going to be 1/20th. So -89 over 20. What's going to be -4.45? So we're going to get 5.55 as our approximation, which is obviously pretty terrible. And again, the reason is because we're so far away from 11. We'll be able to visualize this with Desmos in a little bit, but this is kind of the idea of working with this linearization.